Hello and welcome to the fourth episode of Devomech Insights. I am joined again by the man himself, Waqas Nawaz. How's it going?
It's going great. Thank you for asking.
I see. So today we'll be discussing a lot of different things. We will be going over the product development lifecycle. So could you tell us a little bit about what happens when a client approaches you from the conception stage up until completion? What's that process like? Could you walk us through that a little bit?
Yeah, means most of our clients are entrepreneurs, and what happens is that they feel the need of a certain product in their life, and when they go to market, they're unable to find such a product, and then what they do is that they come up with an idea that why not develop this product themselves, get it manufactured, and sell it into the market and make a business out of it. So usually the clients, the entrepreneurs that reach out to us, they have an idea and they want to get that product designed, manufactured, and they want to sell it, but they have absolutely no idea of the whole process. And I think this podcast would really help all entrepreneurs understand what a standard product development lifecycle looks like.
Interesting. So I guess it's not necessarily just the entrepreneurs. I guess it could even be an individual with a bright idea in their mind. If they see a gap in the market and they feel that it could be solved using engineering concepts, then Devomech is the go-to place for them. And that's what you do, I guess, here at Devomech.
Yes, sure. Means, and the person who has an idea in their mind or gets to know, gets to identify a product gap in the market. Uh, when he starts talking to us, we start calling him entrepreneur. If he was not a month ago, because now he's thinking about doing something that does not exist in the market, and he's planning on developing a business out of it.
Interesting. So not just new ideas. I think if an individual sees that an existing product could be further improved, so anything that involves research and development, anything that is predicated on these concepts is welcomed here at Devomech. Is that right?
Yes, sure. And but we recommend, as far as design improvements are concerned, we don't recommend doing minor design improvements. At least a design improvement should be to a level that could be patent protected. Means if the design change can't be patent protected, then the business is not safe for long term, and then we don't recommend them to go through that. I only recommend those ideas that you can get patent protection for.
Okay, so let me ask you a question. I'll assume the dummy role here because that's not a difficult role for me to assume. Okay, so I come to you with an idea in my mind, and what would be the conversation like? So, for example, I see that I want to design a shoe that I could eventually penetrate the market with. What would our conversation be like, and what exactly could you help me with?
Okay, so I would ask you some questions, and those would include that why do you want to do it? You might tell me that such a product does not exist in the market, and you would want to sell it. Okay, fine. If that is so, then what is your target market? Means what? Who is your target consumer? uh, if you respond to that, let's say that is a middle-aged people or teenage people. So depending on that, then I would ask you that what is the price at which you intend to sell this product, or what is the price at which you can sell it in the market. And from there, I would know that how much the product should cost when mass produced, so that we could have those many features that could be manufactured in that price. And then we asked them a lot of different questions regarding features of that product, that and their vision for that particular business. And when we have all those questions answered, and then we can move forward to developing an initial concept design.
I see. So you get into the intricate details regarding the whys and the hows, and then you set up constraints and objectives with them, with the client, so that you could help them understand what they should be aiming for as well. So, is that right?
Yeah, I mean that is absolutely right. Means uh, mm, so you have to educate some clients as well, because you can't manufacture uh, a product like iPhone and then sell it into the market for $15, because it would cost more than that to
Of course.
manufacture. So you have to have realistic uh, uh, expectations from a product. So yeah, means we help them develop a complete a document which we call initial product brief document, and that contains all the details of what that product would look like, or what would the features of that product. And so we cover everything in that, so that we have a fixed achievables or milestones that what the product would do, and then we can start working.
Awesome, awesome. So let's talk a little bit about smart devices. The world is transitioning towards this umbrella term, the Industry 4.0. Everything is mimicking human-like intelligence in some way or the other. So could you give us an example of a smart device, and could you please walk us through the whole development process from conception till completion, what that would be like? So if you could help us with that.
Yeah, sure. Means we have done developed a lot many products, smart devices. For example, we can discuss a digital display cube product that we did
Sure.
recently. So this product basically is a holographic device, and what you do is that on the gaming board you have different. Normally you have different characters of different shapes, and you just pick one character and put it on the desk war games. So we replaced all those different characters with this product that would make a hologram of whatever the character you want to show, and it is controlled through a mobile application where you can download different characters and display them on your device to play different war games. So usually we call the IoT or Internet of Things or smart devices that are connected through a mobile application or a desktop application. So the whole process of product development, it's a lengthy process, and normally such a product takes around at least 6 to 8 months of research and development till you are able to mass produce it.
I guess that also depends on the complexity of the product that we're dealing with. And the more systems that are involved in a product, so the more complex it becomes, and as such requires more time to research. So, so let's say from an engineering perspective, since I'm an engineer myself, you mentioned digital display cube. So, could you walk us through the mechanical side of things and then take us to the electrical side of things, and then also the firmware side, how you integrated all these systems together, and what was it like for you to, what was your whole experience like with the client as well as with the engineering teams?
Okay, sure. Means so what we can do is right now here that we will take this product as an example and go through the whole different phases. Uh, Usually, the first phase in such a product development is the industrial design, and in that industrial design, our industrial design team develops different concepts of how the product would look like. The industrial design team is experienced in design aesthetics and design user experience. Uh, so they develop really beautiful looking products, renders, models, and then those are shared with the client, and then client gives his input or feedback, and based on that those are further improved. And means they also coordinate with the mechanical team to a decent extent as well. And then those designs are passed over to the mechanical team, as you are the team lead of our mechanical design team, so you would know better than what do you do further with such designs that come to you.
Yes, we usually merge them with, we put on our engineering lenses and we see what could actually be manufactured, because in the real world, we are constrained with a lot of different things. So, for example, if you have to drill a hole through a device, it has to adhere to a certain standard size of the drill bit that we're looking at. And as funny as it may sound, sometimes bigger holes look more aesthetically pleasing than the smaller ones, and it could be the other way around sometimes. So we're restricted by what machines we have, what equipment we have. Um, so yeah, and then we take the concept from the industrial side and we 3D print it. Oftentimes, we develop a prototype, and if it involves different assemblies, we usually do what is known as proof of concept prototyping to ensure the functionality of these assemblies. And then we develop an actual working prototype, which is then shared with the client to receive their feedback. And if they're impressed with our performance, we continue working on it until it can be developed to the point that it could be launched into the market. And I think you are more experienced to, um, I think you would be the best person to ask how to do that. Once we have the product ready, how do we penetrate a potential market? How do you launch it? Once the proof of concept is ready, we have the MVPs ready. How do you penetrate the market? Where do you go from there?
All right. So once you have the MVP ready,
Yeah,
uh, then you have a lot of different options that you can opt to launch your product. Just to clarify, we are a product development company. We do not have a lot of experience on the business side of things.
I see.
We are means our area of expertise is the technical development. So we are very good at getting the products, designing the products, and then getting them mass produced from different manufacturers that we have contacts with in different countries like China, Malaysia, US, Europe, Mexico, Vietnam, India. So we can get them manufactured. As far as launching them into the market is concerned, so that is not our area of expertise. But as we have worked with a lot of clients, and I have observed that different clients have different ways of doing it. For example, some clients opt for going to different public funded funding campaigns like Kickstarter, Indiegogo. They go on those platforms and take the pre-orders, and once they have some pre-orders in their hand, then they invest that money that comes from that campaign into making the injection molds for the production. And so that is how some of our clients fund their initial production, and also that helps them penetrate the market because they know that they have some consumers who are interested in the product.
And transparency, I think that's the key aspect. We maintain transparency with the client from the conception stage till the completion. Whatever conversations we hold with the manufacturers, we share them with the client side as well. So this is something which I really like working at Devomech. I think this is great that we do that. Um, the clients are always on board with us at every step that we take. Yeah.
Yeah, and that's the reason we submit weekly reports to our clients so that they know what's going on. And we are means we encourage our clients to get in contact with the manufacturers directly and discuss with them, share their concerns if there are any with the production companies. So I think means transparency is the key on the Devomech side and on the client side as well. Means if they are aware of the whole process and what went wrong, what went right through the research and development phase, that helps them in developing more products and more versions of the same product. But my question to you would be that how you coordinate with the electronics team to incorporate the electronic features or sensors or PCBs into your mechanical design.
Okay. From the mechanical point of view, we are usually constricted with space. So um, if I may talk about a particular project that we're working on, if that is okay.
Sure.
Okay. So we're working on a hand pooling device. And initially, we maintained this approach that we had to integrate a heat sink in a confined space. But the way we did that left very little space for the electronics team to integrate their circuits and to integrate the sensors in place. So it was a conversation that went back and forth. Hey, can you reduce the size of this heat sink? No, we can't because we need this much surface area in order to dissipate this amount of heat. Otherwise, the whole thing won't perform anyways. So we are restricted in a lot of different ways. So one way we address that challenge is by giving space to the other teams. So we're like, okay, fine. How much space do you need to integrate all of these electrical components in our design? So usually when you give a lot of options to other people, so they get defensive and insecure. But once you reassure them that we are on the same team, so we usually let them decide the constraints for us, and we try to wrap our mechanical design around their constraints. So that's what we did with this hand cooling project as well. I would not like to go into further details of it until the product is out. So yeah, but I think communication is the key. And again, a lot of it has to do with the number of systems involved in a particular product. So if you have, let's say, a very complicated system hierarchy, we have a mechanical system, we have an electrical system, we have different control systems integrated within one product, especially if it's smart devices that we're talking. It may seem simple to the naked eye, but it's not really simple. I think any smart device, anything that you pick, there's a lot of effort and engineering that goes into it. If it's a tangible product, someone has thought it through. That's why you have it in front of you.
Exactly, and I think that electronics and hardware electronics, firmware development, and mobile app has to go hand in hand with the mechanical team. So all teams have to work together to ensure that they reach. So just so overall, in the whole product design cycle, I think that it starts with the industrial design team. They do the aesthetics designs, and then it goes towards the mechanical design team. Mechanical design team coordinates with the electronics design team, that what are the components that will go into it, what will be the PCB size that will fit into it, what are the sensors that you need to install in the product.
Absolutely. All the while remaining in the cost constraints which are dictated to us by the client. So
Yeah.
oftentimes a solution might be there for us, but since we're so restricted by the amount of money that the client is willing to spend, we're not able to integrate that solution. So to any other engineer, a solution might be there for a particular problem. But again, it all depends on what restrictions are there in place for a particular project.
Exactly, means you client has to look in the market that how much he can sell it for as well. Okay, so mechanical team and electronics team coordinate together and they make a product that in which whole electronics can fit in. And in parallel, the firmware team is also developing the firmware for the smart device as well. And the app development team in parallel is developing the app for it. Definitely, the app development team has a UI UX designer that does the UI UX first, and then the developer develops that app. So I think the electronics hardware and mechanical team have this pressure that you need to develop a functional prototype so that the firmware development team can test their firmware on this product, and also the app development team can also integrate their app with the hardware device to make sure that it can communicate with the server and the mobile app to provide any data that is required to the app or the server.
That's true.
So this first prototype that you usually develop uh, means what is how is it good looking or not first, and second means what is your usually success criteria for the first prototype.
That's a deep question. I think it varies from individual to individual. If the client is too adamant about having the product maintain its aesthetic appeals, then we are then we let the industrial team govern those constraints for all the other teams. But let's say the client is more so about making a functional prototype, then we let the engineering teams govern the rest of the constraints. So once we have a functional prototype in place, oftentimes we give it back to the industrial team to make it more aesthetically pleasing to the customers and to the clients. So there isn't a template based answer for this question. So yeah, it depends really on who the client is, what the product is uh, supposed to do, what market it's supposed to penetrate, what the client has in their mind, whether the client is an individual or a company. I think it depends on all of these factors.
Yeah, I totally agree to that. But usually, I think the first prototype has this. If you get to test all the features,
Yes.
then it means that your major technical expectations from that prototype are met. And then the client, all the clients are not always technical and do not have their technical expectations. So they are more into that how it looks, how it feels, and then you do according to that. All right. So so once you have a prototype, you have tested it, it's working fine, it's a good functional prototype. So what do you do from there?
We communicated to our boss.
Means what is the next step? Especially how do you prepare it for ready for manufacturing, or how do you do further iterations? So what does the process look like?
So, what we do on the mechanical side is prepare the prototypes based on DFM guidelines and DFMA guidelines. It should be easy to assemble. It has to be foolproof. So the guy doing the machining, the technical staff need to know what they're doing, and so we have to keep all that in mind from the get go. So what screws we have to use, what bolts we're going to use, what. So we keep all of that in mind. So I think we've discussed quite a lot on the mechanical side of things. Let's also get into the details of the electrical side. Could you shed some light on what the electrical development process is like for any product?
Yeah, sure. Means so on the electronics design side, the electronics design team first makes a flow diagram of the whole system, that how it would look like, and then they select different components that they will use. If it would be a battery, what would be its size, what would be its shape, what would be its type, and then if they are selecting different component, what and which microcontroller they would use, what are the features they need in that product, how much is the computational power required in that particular device. So they select the certain microcontroller, be it ESP32, it can be a Raspberry Pi if more computational power is required, it can be a Jetson if they are integrating AI and doing some video processing. So based on all these constraints, they select the brain of the device, and then they select all other sensors, components, be it a temperature sensor, it can be a pressure sensor, it can be a speaker, it can be a light, it can be a rim light. So whatever all other components are being used in that, it can be a heating element as well. So all other components they select accordingly. So once they have selected all the components that they are going to use in that certain product, then they design a PCB, printed circuit board, for that particular device, and there they coordinate with the electron mechanical team. They get the DXF file from you so that they can design the PCB on that. And once the PCB is completely designed, then they develop the PCB in our prototyping lab here, and they test it out and make sure that it works well. And once they are satisfied with the whole design, then they get it manufactured from China usually. Because here in our lab we are restricted to making a two-layer PCB. Usually the complex PCBs where you need in compact devices, those are 4 or 8 or even more layers PCBs, so which are manufactured from China usually. And then we import those, we put in the prototype, test them out. Meanwhile, the firmware development has developed all the firmware. The firmware is basically a software that goes into that microcontroller or a computer, the brain of the device. So that controls, that is a software that controls the whole device. So the firmware team usually develops that in parallel, and when you have a functional prototype, they burn that software into the device, and then they test it out and make sure that the device is working as expected. Definitely in your first test, there are some bugs, issues here and there, so they solve those based on their testing on the prototype. And in parallel, you have, if that product is sending some data to the server, so you have your our software team tests the prototype with their server, making sure that the data that this device was supposed to post onto the server is being posted smoothly or not. And then the app development team also test their app with the prototype to make sure that the device can pair on the application. It can be controlled through that. All the data that is to be transmitted to the app is receiving it efficiently. So the electronics, firmware, server, and app development, this all goes hand in hand along with the mechanical team to ensure that the device functions as it is supposed to do. Now, on the firmware development and server side is a bit more complex than it sounds, because on the mechanical design side or on the electronics design side means you're only focused on designing one product. On mechanical team has to make for example a certain enclosure or some moving parts, but they are doing that for one product. Electronics design team, they are developing a PCB for one product, whereas the firmware development team and our app development team along with the server side, they have to keep in mind to manage thousands or millions of products. For example, if you have a certain server where 1 million devices are posting their data to, first they have to identify which data is coming from which device, and then they have to make a usable outcome from that, certain graph, certain data interpretation, how that data can be utilized. So they have to design their systems for a certain scale, be it millions, and usually it's millions. They design it for that, because if a customer is using your product and that is posting some data to the server and is connected to a mobile app, then you have to gather that statistics, that how much devices, let's say, are experiencing any malfunction, how many devices are what is their life cycle looks like, if any product needs a certain repair or etc. And then if those and if let's say you have a million devices, those are temperature sensors, let's make it very simple, and you have installed them around the globe, and you have to measure the temperature of all those regions. So all those devices are transmitting data to your server, and your server is collecting that data, and then it has to present that in a certain form. It has to detect which data is coming from which device, and then present it in a usable form. For example, we have designed a product which is called a water project. So this is basically a TDS and flow sensor for different water filtration plants, and this company has water filtration plants around the globe. So we have designed their products for them. So what happens is, when they have installed those devices in different countries, but they have one web application where all those devices, they can see all those devices, how much water flow is being passed through that device, how much water passed through that device in the last 24 hours, in the last month, in the last year, and what was the average TDS of that water in a certain time period.
When you say TDS, what do you mean exactly?
Total dissolved solids. So this is how much pure the water is.
I see. Okay.
And based on that, when our web application detects that the TDS is raising and flow rate is going down, that means that the filters need to be replaced. Then it will give a notification or an alert to them that the device in that particular country, in that particular location, because it collects the location of the device as well. At that particular location, please replace its filter. So our client sitting at one computer knows what's going on with their products around the globe.
Wow. Interesting.
So our firmware development team and our server development team, web application development team and app development team, so their role is to ensure that their design works good at a certain scale, be it millions.
Interesting. So, a quick question. When it comes to reliability of the products, say, for example, in this device, you must have used different kinds of sensors. So, and how do you ensure that each product is working the way it's supposed to work? In other words, the quality of what we're manufacturing.
Okay, so actually we follow certain standards. For example, if there's an outdoor device, we will use certain IP rating for it to make sure that no water or dust ingress happens. If it is being used in the sunlight, we will ensure a certain material that won't degrade with time. And same goes on the electronic side, means if the device has to go certain vibration under vibrations or is being used in a certain car or a vehicle, then we use automotive grade components on the electronic side so that they do not fail under that. So we design everything for the environment that they are going to be used. So and we test them rigorously before launching that product to the market. So there are very less chances that anything go wrong. But in this water project specifically, we tested them at different locations here near our office, at different locations of the or of our client. So it was working fine, but they deployed some of these filtration units in different countries in the far off areas where there was not even 3G signals. And even we were not able to find 2G signals at some locations, and so devices were not able to post the data. So then we had to improve on that. So we designed our system such that the SIM that was SIM card in that application, instead of posting data into the internet directly, it was sending simple SMS messages to our server, and our server was interpreting those messages and then posting that data on our web application. So yeah, means problems do happen, challenges do happen, but we are able to solve them. We are always find a way around them.
Which is the engineering challenge, finding solutions to different problems. With that, another question that I have is, are these devices hackable? Or like, how do we prevent that from happening?
Okay, I'm a mechanical engineer, so I'm not sure that I am the right person to respond to this, but there are certain security protocols that you build into your firmware and your mobile application. So we follow certain security standards to ensure that the devices can't be hacked. So now there are different levels of those security standards. For example, if it is a medical product, and the data that it is posting is very personal data, it is related to a certain person, then that goes to a higher security standard. Then we are very strict in our security standards to ensure that no data leakage can happen. Let's say it is a general data where you are posting a temperature of a certain location. So this data is not that critical, it is not that personal. You still don't want your product to be hacked, but the security level of security would be a bit down than the data where personal data is applicable. Especially in Europe or some countries, these data securities are very important because one lawsuit can kill the whole company if the data is breached. So we ensure that we follow the rules of a country in which the product is going to be launched, and we also make sure that any data breach could be avoided. We are also ISO 27001 certified, so which is related to the data security.
I see. Awesome. And I think I would like to add to that, once a product is ready over here, we also run what is known as the failure modes and effects analysis, which is we imagine every possible scenario in which a product could fail, and then we build mitigation strategies around those failures. So to any viewers or listeners out there, be satisfied your product will be safe, reliable to enter the market.
Yeah, sure. And we call it stress testing as well. Means we test the product until it fails. And sometimes I do the destructive testing.
Destructive, that's the fun part, right?
Where you get to break the product.
Yes. That's the fun part, especially on the mechanical side. The amount of things that we get to break is just sometimes heartbreaking for probably for the owner, but it's really fun for us. So, you know, what I really like about, again, I'm tying this back to the mechanical side once again, is when we run analysis, when we have a 3D model, but when we do some analysis on simulation side, you know, could be static simulations, could be transient simulations, steady state simulations, and then once we get to verify those results, that is the fun part. That is when you really feel satisfied, you know, with your assumptions and with all the uh, estimates or the assumptions that you're going to make to produce your product. Yeah, and then it has to go through all those different iterations again and again.
I think, yeah, I mean, so for an engineer, I think this sense of accomplishment is very important, and you get that at different stages of the product. Initially, if you have simulated certain, and then those, if those results are verified, then you feel accomplished. You have designed a product, and a prototype comes in front of you, and it's working and functional, something tangible.
Yes.
That also gives a sense of accomplishment. And then once after you have designed it for manufacturing and first sample of mass manufacturing comes out and it looks great, then you really have that sense of accomplishment and a good feeling about it. And and then when that product is launched in the market and it performs great and our clients make millions of dollars, that gives again a sense of accomplishment to us, that the products that we designed are doing really well in the market and gathering a lot of good reviews on different platforms. So yeah, I mean, there are different levels at which you get that sense of accomplishment, because ultimately the goal is to make products that make this world a better place to live.
Yes.
So yeah.
Okay. Waqas, could you please tell us a little bit more about what standards do our products have to comply with in general, like CE or ISO or
Yeah, sure.
FCC?
Means it depends on the product that and the country in which it is to be launched. Usually, the CE certification is important for all the electronics devices. So our devices comply with CE certification. For that, you have to send one of production samples to the lab, and they test it for you, and then you follow. There's a certain process, and our clients get the CE certification. Then it also depends, if it's the medical product, then our clients would need ISO 13485 certification. Along with that, they may require some other approvals, if either in Europe or US, whichever country they are from. So we assist them with all the documentation that they need to get those certifications. And there are some certifications that are not essentially required, but we encourage our clients to get them. For example, if the device is being used outdoors, then we ask them to get the IP certification as well. And usually they send it to the lab, and if the product is simply outdoor, then we ask them to get an IP65 certification. And if the product is in any case to be submerged in water, then we recommend them getting IP67 or IP68 certification.
I see. Interesting. That sounds awesome. So, any final key takeaways or any closing remarks for the viewers or the listeners out there?
Yeah, sure. Means I would say this to all the entrepreneurs or the business owners who are about to start their own product development. So I would say that be patient. The process, any smart device development process would take at least 6 months and can go up to 2 years depending upon the complexity of the product. So be patient and follow the whole design cycle. Do not take any shortcuts, not compromise on testing, iterations, improvements. So take your time before going to mass production, because once you go to mass production, then you have very little room left for improvements in that variant, because injection molds are manufactured, the final PCB tests have been done, the firmware, and also in your firmware development and web application development, mobile application development, please keep the scale in your mind while developing those, because if those should be friendly for mass production. Means if your system or shouldn't choke if 1,000 devices are connected to it, Rather, it should be designed such that millions could be connected to it and it would still perform. So yeah, and then I would wish all entrepreneurs best of luck with whatever they are doing, because it is not easy. As people say that if you feel in a startup life, if you feel like you have everything under control, that means you are moving too slow. So. So no, everything is not everything is not in your control. You don't feel that control in startup life, and that's a part of it. Enjoy it, and best of luck with whatever you're doing.
Get comfortable with being uncomfortable.
Yeah.
I see. Interesting. Thank you so much, Waqas, for being here with us today. It
You
was
are
a pleasure speaking to you.
You are
Thank
most
you.
welcome.
I wish you the best.
Thank you.